Discuss problem number 3. Determine the values of R sub n, M sub n, and M sub u of the beam shown below. Use NSCP 2015. So for this one, meron daw tayong 300 na width na beam by 600 na height. So itong 600 na to, ito yung kabuuan na height ng beam natin. So yung gagamitin daw natin, dito meron tayong apat na 25 mm diameters ng bar natin. So for the design parameters, meron tayong value ng F prime C natin na 20.7 megapascal and the value of your Fy na 345 megapascal. And yung given na concrete clear cover, that is 50 mm. Sir, ano po yung concrete clear cover na yan? So from the word itself, clear cover. So meaning to say, so kung i-magnify natin ito, so let's say ito yung mga bakal natin. So meron tayong apat na bakal daw. And isasama ngayon natin yung ito yung stirrups natin o yung anilyo. So pag sinabi natin concrete clear cover, ito yan. So ito yung magiging base natin. So meron daw tayong 50 mm na clear cover dito. So from the face ng ano natin, stirrups natin, hanggang dun sa extreme fiber intention natin, meron kang 50 mm. Sir, bakit po merong given na concrete clear cover? Para makuha natin yung value ng effective depth natin. So what is effective depth naman? From the center of your reinforcement bar to the extreme fiber in compression. So this is what we call the effective depth na small t. So with this, let's solve. So yung for the code requirement for NSCP 2015, for main bars, 28 mm diameter and smaller, use a diameter of stirrups of 10 mm. Since yung 25 mm is less than to the value ng limiting value natin na 28 mm diameter bars, therefore, we are going to use na diameter ng stirrups natin na 10 mm. So first, para ma-solve natin yung problem natin, we need to find first for the value of your effective depth. So in computing for the value of your effective depth, so yung total height natin na 600, so minus lang natin yan yung concrete clear cover natin na 50, minus yung diameter nung stirrups natin na 10, minus yung kalahati nung main diameters natin. So we have 25 over 2. Kasi yung goal natin is from the center ng reinforcement natin hanggang dun sa compression, dun sa extreme compression fiber natin. So, the value of your effective depth is now equal to 5 to 7.50 mm. So, after computing for the value of your effective depth, i-check ngayon natin yung ductility niya. Sir, bakit po natin tina-check yung ductility? So first of all, yung one of the reason dito is para ma-check natin kung singly reinforced ba yung beam natin or doubly reinforced beam. So pag sinabi natin doubly reinforced beam, pati sa compression side natin, meron ka ng bakal. Kaso nga lang, for the singly reinforced beam, yung bakal natin is nasa tension side lang. So in checking for the ductility, hahanapin muna natin yung seal ratio minimum natin. I-compare natin yan to the actual raw natin or yung actual seal ratio at saka yung maximum steel ratio. So, compare natin yan, hahanapin natin yung mga yan. So, if yung yung actual raw natin, that is greater than the raw minimum, and less than to the value of your raw max, therefore, magiging okay tayo dito. So, first of all, hanapin muna natin yung value ng raw minimum natin. So, yung raw minimum natin, meron tayong dalawang values dyan, yung 1.4 over yung FY natin. So, yung FY natin, that is, meron tayong value na 345 megapascal. Substitute lang natin. So, you will have a value of raw minimum na 0.0041. And then, meron pa tayong isang value ng raw minimum natin. So, that is equal to square root of F prime C over 4Fy. So, yung value ng raw minimum natin is now equal to 0.0033. So, meron tayong dalawang values ng raw minimum natin. So, in considering raw minimum, since minimum yung kinukuha natin, so, gagamitin natin is whichever is the higher value between the two. Since mas mataas etong raw minimum natin sa naunang formula, we will going to adopt the value of raw. So, this will govern. Next naman, by NSCP 2015, since gagamitin natin is NSCP 2015. So, as a recap lang, no, kapag NSCP 2001, hahanapin mo muna si raw balance para makuha natin si raw max. Kaso nga lang, sa NSCP 2015, meron na tayong formula for raw max agad. So, which is equal to 0.85 F prime C beta over Fy multiplied by 3 over 7. So, eto using NSCP 2015. Ngayon, yung problema lang dito, what is the value of your beta? Diba? Yung F prime C natin dito, we will just go back to the value ng F prime C natin na 20.7 megapascal. And we will just compare that to 28 megapascal. So, kapag NSCP 2015, 28 megapascal yung limiting value. Kapag naman 2001, 30 megapascal naman siya. There, since yung F prime C natin is less than to the limiting value, therefore, beta is equal to 0.85. So, substitute lang natin yung values natin dito. So, let's substitute yung F prime C natin, which is equal to 20.7. So, this is equal to 20.7. Yung Fy natin, na merong value na 345. And yung beta 1 natin na 0.85. So, you will have a value of your raw max, which is equal to 0.0186. So, after computing for the value of your raw max, hanapin ngayon natin yung raw actual. So, yung raw actual natin, that is simply yung area ng bakal natin on the actual and yung BD. So, ilan ba yung bakal natin dito? Meron tayong 4 na 25 mm diameter bars. So, 25 mm diameter bars over yung B natin na 300 and yung effective depth natin na 527.15. So, the value of your raw actual is now equal to 0.0124. Wherein yung raw actual natin, that is greater than to the value ng raw minimum natin, but less than to the value of your raw max natin. So, meaning to say, nasa sagely reinforced beam tayo, and at the same time, magiging okay yung ductility check natin. So next, let us now compute for the value of your RN, MN, at saka MU naman. So paano natin yan ginagawa? So una is, we will going to begin with an assumption. Assume muna. So lagi tayong nagbibigin with an assumption na tension still yields. So, kapag tension still yields tayo, so remember the formula for T, diba? That is AS, FS. Okay, laging ganyan yung formula natin kahit nabalikan natin sa WSD. So kapag nag-tension steel yield tayo, yung value ng Fs natin na to will be equal to Fy. So assume tension steel yields muna na tayo. So C is equals to T, or T is equals to C. So this is 0.85 F prime C. A, B is equals to yung ano natin, AS. So instead of Fs, gagamitin natin si Fy. So substitute natin yung mga values natin dito. So you will have 0.85. Yung F prime C natin na 20.7. So yung A, yun yung hinahanap natin. Yung width natin na 300. And the value ng AS natin, that is meron tayong 4 na bakal na merong diameter na 25 mm. And yung Fy natin, we have a value of 345 megapascal. So we can now calculate for the value of your A, which is equal to 128.33 mm. So since we have the value of your A, makukuha na ngayon natin yung value ng C natin. So yung C natin o yung distance of from the neutral axis to the extreme fiber in compression natin, that is only equal to A. I-divide lang natin siya to the value of your beta. Yung beta natin, nakuha na natin siya kanina, which is equal to 0.85. So the value of your C is now equal to 150.98 mm. Sir, bakit po natin kinuha yung value ni C? So, if you have the value of your C, malalaman natin kung tama ba yung assumption natin or hindi. So, di ba dito, we assume na tension still will yield. So, after assuming and nakuha natin yung mga values natin, we will going to check if the steel really yields. So, i-verify ngayon natin. So, we will going to verify or check if tension still yield. So, paano po natin yan i-check, sir? So, kapag yung nakuha natin na strain nung steel natin, that is greater than or equal to the value nung strain natin sa yielding. So, hanapin muna natin yung strain natin sa steel. So, that is 0.003 multiplied by D minus C over C. So, substitute lang natin yung mga values natin dito. So, you have, so yung value ng D natin dito, this is 527.5. So, this is 527.5. Tapos, yung C natin, which is equal to 150.90. So, substitute lang natin yung mga values natin. So, you will have a value of your epsilon S, which is equal to 0.00748. Then, we will compare that the value of your epsilon y or yung strain natin sa y. So, yung formula natin dyan, that is Fy over Es. So, yung Fy natin, we have a value of 345 megapascal. And yung Es natin, that is 200,000 megapascal. So, the value of your strain here is now equal to 0.00175. Since, so i-compare natin, since epsilon S, which is equal to this value, is greater than to the value of your epsilon Y, therefore, assumption correct. Tension still yields. Okay. Next, So, nalaman na ngayon natin na tension, yung assumption natin kanina is tama. So, meaning to say, we will going to proceed in computing for the remaining values na hinahanap sa problem natin. So, let's solve first for the value of your nominal resistance. So, yung formula natin for nominal resistance, that is rho Fy, 1 minus rho Fy over 1.7 F prime C. So, substituting yung mga values natin dito, yung nominal resistance natin. So, yung actual rho natin, which is equal to 0.0124. Yung Fy na given natin na 345 megapascal. 1 minus yung rho natin na 0.0124 multiplied by 345 over 1.7. Yung F prime C natin na 20.7. So you will have a value of your nominal resistance which is equal to 3.757 megapascal. So this will now become your answer. So after computing for the value of your nominal resistance, hanapin naman natin yung nominal moment natin. Sir, paano po natin kukunin yung nominal moment natin? It depends kung gagamitin mo is yung C or gagamitin mo naman is yung T natin. So for this problem, gamitin na lang natin is yung sa. Kahit na ano kasi yung gamitin mo is halos parehas lang yung kalalabasan na answer doon. So for this, gamitin natin parehas para ma-check lang natin and ma-justify yung statement natin. Let us now solve for the value of your m sub n. So kung sa konkreto yung gagamitin natin, ano yung formula natin dyan? So that will be m sub n is equals to, so yung C natin, di ba, multiply natin by yung moment arm natin na D minus A over 2. Yung C natin, that is 0.85. F prime C, A multiplied by B. D minus A over 2. So if we were going to, so we have 0.85. Yung F prime C natin na 20.7. And then we have a value of your A na 128.33. And yung width ng beam natin na 300 multiplied by 527.5 na effective depth ng beam natin minus yung A over 2 natin na 128.33 over 2. So the value of your nominal moment resistance is equal to 313.856 times 10 raised to 6 Newton mm. So sa pag-substitute ng mga values natin, dapat naka-megapascal tayo or naka-mm tayo para maging uniform yung mga units natin. So for this one, para maging kilonewton meter yan, alisin lang natin yung times 10 raised to 6. So you will have an answer of 313.856 kilonewton meter. So, mag-reference naman tayo dun sa steel. So, sa steel naman, nominal moment resistance, that is T multiplied by D minus A over 2, which is equal to yung T natin, that is AS, Fs, multiplied by D minus A over 2. Kaso nga lang, diba, na-check natin na tension still will yield. So, meaning to say, Fs will now equal to the value of your Fy. So, magiging AS Fy, D minus A over 2, yung formula natin in computing for the value of your nominal resistance sa steel. So, AS, so meron tayong 4 na bakal. Tapos, yung diameter niya is 25. And yung Fs natin, that is Fy, kasi nga tension still yields na 345 megapascal. Yung effective depth natin, that is 527.5 minus 128.33 over 2. So the value of your nominal moment is now equal to 313.866 times 10 raised to 6 Newton mm. Therefore, alisin lang natin yung times 10 raised to 6, magiging kilonewton meter na siya. So, for this one, use na lang natin yung smaller value between the two. Kaso nga lang, halos parehas lang naman yung answer natin. So, etong na ngayon yung magiging answer natin for the nominal moment resistance. Then lastly, we are tasked to solve for the value of your ultimate moment capacity. O yung tinatawag nating M sub U. Sir, paano po natin kinukuha yan? So, ginagawa lang natin is, minumultiply lang natin yung nominal natin to a certain reduction factor. So, what will be the reduction factor natin? It depends kung nasa ang region yung kung nasa ang region ka, kung tension control ba yan, compression control, or transition control. Sir, paano po natin malalaman kung nasa ang region po tayo? It depends upon the value ng E sub S natin. Okay. So, yung E sub S natin, this is 0.0748. So, in computing for your reduction factor, as I said a while ago, so, compare lang natin yung nakuha natin na actual na strain ng steel mo to the value na 0.005. So, compare natin yan to the value na 0.005. Since greater than yung epsilon S natin na 0.00748 to the value ng limiting value natin na 0.005, definitely yung gagamitin natin na reduction factor, that is 0.90 or nasa tension control tayo. Okay? And then naman, kapag naman yung strain natin, that is kapag naman meron tayo pang compression control and transition control as discussed naman dun sa module natin. So eto, since greater than yung strain sa steel natin to the value ng 0.005. So, yung reduction factor natin, that is 0.90. So, yung MU, that is 0.90 multiplied by M sub N natin na 313.856 kilonewton. So, MU is now equal to 282.47 kilonewton meter. So this will now become our value.